Okay, YouTube, this is my first video in my module on multiplying and dividing rational expressions, in which we're going to do a lead-in with a discussion of simplifying rational expressions before we even start multiplying or dividing. So let's go ahead and recall a few things here, starting with the fact that a rational expression is just a fraction or a ratio whose numerator and denominator are non-zero polynomials. So for instance, if I had something like x plus 1 over, I suppose, x squared plus 3x plus 2, this would be considered to be a rational expression. So a few things we want to say about this. First of all, that the domain or the set of inputs or x values of a rational expression excludes values that make the denominator 0. So that is to say that when we look at something like this down here, we say what could cause this to be 0, it would be really easy for us to go ahead and set this equal to 0 and solve it. But what you see is by solving it, what we're required to do is actually factor this expression. And so we can see that in this particular case, looking at this expression here, if we were to use x values equal to -1 or -2 and plug those in, say either down here or down here, we could see that we end up with a product of 0. So in terms of the domain, we would say the domain is all x values, all x values such that x cannot be equal to -1 and -2. And with respect to simplified form, we say that a rational expression is in simplified form when its numerator and denominator have no common factors other than 1. So for instance, up here when we look at this expression, we say x plus 1. After factoring the denominator, what we can see is that I have x plus 2, x plus 1. But in terms of canceling out common factors, we can see that the top and the bottom here both have an x plus 1, leaving us with this new expression 1 over x plus 2, which we would say is in simplest form, because looking at this now, the top and the bottom share no other common factors other than just 1. So in terms of simplifying, our goal will be to take such expressions such as this right here, AC over BC, and look for common factors like C on top and bottom, where we could cancel those out and end up with a simplified expression where, let's say, A and B share no other common factors other than 1. So we would say letting A, B, and C be rational expressions with B and C not equal to 0, so we don't have zeros in the denominator. Essentially, we can cancel out common factors on top and bottom. So numerically speaking, we do this all the time, something like 15/65. Often we just say things like, well, hey, 5 goes into both. But really, in reality, what we're doing is we're saying that on top, if we factored it, okay, factored form would be 3 times 5. These would be its prime factors. And if we look at the bottom here, there are its prime factors. Once we factor the top and the bottom completely, we can really easily see that 5 is a shared factor here. And so we end up with 3 over 13, which must be in simplest form, but only because the top and the bottom now share no other common factors other than 1. So another example, this might be what we see here. We have 4 times the quantity x plus 3, or the number x plus 3, over x plus 3, x plus 3. And so we can see that one of these x plus 3's cancel out on top and bottom. We get left with 4 over x plus 3. And again, it's in simplest form because the top and the bottom share no other common factors other than 1. So when we talk about simplifying a rational expression, usually it just comes down to 2 steps. First, 1, factor. Okay, factor. And then 2, cancel any common factors. And so this is going to be our process when we simplify things. So for example, something like this here, x squared plus 7x over x squared. A couple things I want to say about this. First of all, x squared plus 7x over x squared here. The very first thing we want to do, of course, is factor. So on the top, we look for things, factoring patterns, like greatest common factor. We can see that if we factor out an x out of both of those, and this is over x squared, this is really the same thing as x times x. What we end up having happen is that we lose an x on top and we lose an x on bottom. So what we get is this x plus 7 over x. So that process is simple enough. One thing that I want to make sure that we do is require ourselves to list a domain. So when we talk about domain, we say what are some values of x here, if any, that we should exclude from the domain. And so what we're going to do is we're going to write a little note here. We should exclude from the domain any x values that cause your denominator to be 0. So we'd say exclude from the domain any x values, or I'll say or variable values that cause the denominator to equal 0. And so the way we're going to do this is we're going to set the denominator equal to 0 and solve for the 0. So find these by setting the factored denominators equal to 0 and solving. So once we do this here, let's take a look at what we had up here. The very first thing I want to do is look at the initial expression, and I want to say, well, what are the values in this denominator here that would cause this denominator to equal 0? So if we were to take this x squared and set it equal to 0 here, we know that this only ever happens if x equals 0 or x equals 0. So one thing that we would exclude from the domain of this, we would say the domain, okay, we have to exclude 0. X cannot be equal to 0. And then as we look at this expression over here on the bottom of this, and we say set it equal to 0, x equals 0, you can see that we get the same thing here. So the domain of our expression here would be any values that cause the denominators before and after simplifying to be equal to 0. We're going to get those out. So let's take a look at example 1 here, talk about simplifying this rational expression. And we're going to break it down to really easy steps, starting with you just factor the top and the bottom here. So factoring the top and the bottom, I notice that the top is a trinomial where my a value is 1. So I'm looking for two factors of negative 12 that add up to be a negative 4. And so I recognize that negative 6 and a positive 2, if I were to multiply a positive 2 and a negative 6, give me a negative 12, and they add up to be a negative 4. So our top factors into this, and it doesn't factor anymore. And our bottom, being a difference of squares there, we could factor this into conjugate pairs, x plus 2, x minus 2. So looking at this, the very first thing we want to do is talk about the domain. We say we should exclude any x values that cause the denominator to be 0. So we can see that if x is either a negative 2 or a positive 2 here, that we're going to get an undefined value. And so we're going to say x cannot be equal to plus or minus 2, or we could even list 2 and negative 2 here. But going ahead and simplifying this now, we're looking for common factors on top and bottom. It looks like x plus 2 is shared by the top and the bottom. So we get left with this new expression, x minus 6 and x minus 2. And one thing that I want to mention about this is we should check the domain on this also by setting this equal to 0. But we get x equals 2, which was already one of our restricted values here. So we say the domain of this, we cannot include 2 or negative 2, and our simplified form would this be this form over here. So looking at these last examples down here, we can make these pretty quick, but we're looking to factor first, restrict the domain, and then simplify if possible. So in terms of number 1 here, factoring first, you'll notice that everything's already factored. We already look like we cancel out an x plus 1. In terms of domain, our x values that we should exclude are any that would cause this to be 0. So if we set x plus 1 equal to 0, then negative 1 would be the x value we get when we solve that. And if we set x plus 3 equal to 0 and solve it, we get negative 3. So we should exclude these from the domain, but afterwards, after canceling these out, we get left with our simplified form here, which is just 2 over x plus 3. We would say that this is our simplified form. And again, if we set this equal to 0, x plus 3 equal to 0, then we would get x equals negative 3, which is already on our list of restricted things. So the only reason I mention that is because sometimes in your simplified form, you have a new restriction that wasn't already listed on the left-hand side. So looking at number 2 here, this looks very similar to the one we did up on example 1, except for the top is already factored, and the bottom is this difference of squares that factors into, it looks like x plus 4, x minus 4. So again, once you've factored it, let's restrict our domain. It looks like we should exclude either plus or minus 4 because setting these factors equal to 0 and solving them give us these values. And then in terms of our simplest form here, well, we can see that the number x plus 4 cancels out on top and bottom. So on top this time we're going to leave a 1. I'm going to write my simplified form down here and we say 1 over x minus 4. And we certainly should always check this to see if there are any new restrictions, but setting x minus 4 equal to 0 and solving it gives us a positive 4, which we've already named up here as one of our excluded values. So for these last two here, looking at number 3, factoring the top. Now I do want to do this. 4 does factor. So I'm going to factor this into 2 times 2. That's as small as we could factor that because we've broken it down into prime factors. So looking at this, we say top and bottom. We have a 2 and a 2 as our factors. And on the bottom we have an x and an x plus 2. So it looks like we share no common factors here. And so one thing we could write about this, before I guess we should write the domain, if we set x equal to 0, we just get 0. And if we set x plus 2 equal to 0, we get negative 2. So we'll exclude these from the domain, but essentially what I want to tell you is this is already simplified, already simplest form. So for our last one here, we're going to have to, of course, factor the top and the bottom if possible. It looks like the top here would factor into x minus 3, x plus 1. And the bottom here looks like 2 factors of negative 6 that add up to be a negative 1. I suppose we would get an x minus 3, x plus 2. So something like this here, x minus 3, x plus 2. When we look on the top and the bottom, it would be fairly tempting, I suppose, to say that x, well, I guess x minus 3 isn't common. I thought 1 was a plus here. Sorry, these do indeed cancel out. And before we do this, let's go ahead and restrict our domain. We say x cannot equal a positive 3 or a negative 2. But also on our simplest form, x plus 1 over x plus 2, where they share no other common factors other than 1, the top and the bottom tone. We can see that x cannot equal negative 2 either, which is one we've already listed here. So simplifying these, factor the top and the bottom, restrict your domain if necessary, and then cancel out any common factors, writing it in simplest form. Cheers.